In this video, we are going to go over section 3.2, which is derivative of exponential and logarithmic functions. Now, in the last video, last section, we practiced getting familiar with exponential e function. You had a homework problem where you have to use the limit definition, plug it in really high n value, and then you found out that E was approximately 2.71, and then keep going. Also, we deal with the ln function a lot when we were solving the problem to bring down the power when we were dealing with the application problem, the compound interest. Now, this section, we are going to add on the topics on derivative. So 3.1 was more algebra, something that you are familiar. 3.2 is a calculus topic, which is derivative. So there are four derivative rules on the exponential and logarithmic function. First one is derivative of, the term d over dx is a notation for derivative. So derivative of e to the x is just e to the x. Very easy one to remember. Derivative of ln x is 1 over x. Okay. Derivative of b to the x, this is like b can be any number. So for example, like derivative of like 3x. Okay. That's not, do not get confused. We had a derivative function in the past where x raised to the cube, that was 2x. Okay, but this, now they switch, right? 3 is your base, x is an exponent. In the past, you had an x as a base and then 3 as exponent. So these two are different. Variable on the top, variable on the bottom. When you have 3 raised to the x, the derivative is 3 to the x, b to the x, ln of 3. Same thing, log of x base b, any base b, it is ln of 1 over ln b, 1 over x. So you can kind of see similar, right? You have 1 over x here, 1 over x, but 1 over ln b, because log of b can be any value. Ln is particularly log of base e. Same thing, e to the x, so b to the x, b to the x with the ln b, because b can be any number. So we will be using these formula to help us take the derivative. So this section is just drilling, practicing derivative of these exponential and logarithmic function. Now, I want to have you guys recall a couple properties from algebra on those log functions, okay? Because we will be using these algebra tricks to take the derivative in a minute. So recall, one of the rule that we have regarding log is product rule, right? ln log, same thing. So you have log of a, let's say u times v. This can be rewritten as log of a. The product changes to addition, log of a v, right? Similarly, ln is a particular base. ln of uv changes to ln u plus ln v. We have a quotient rule as well. The quotient rule was, if you have a log of a u over v, that changes to subtraction, right? So log of a u minus log of a v. Similarly, ln of u over v is ln u minus ln v. Lastly, there are more, definitely, but these are a couple that I want you to recall. Log of a u raised to the n, and we used this one in section 3.1. You can move down the power as a product, so n times log a u. Similarly, you will have ln u raised to the n, the same thing as n times ln u. So these are some properties that we will be using to make the problem simpler and then apply the derivative. Okay, so let's do a first problem. Now, first problem, you have 1, 2, 3, 4, 4 terms. So we will take derivative term by term. So looking at one term at a time. All those derivative rule in terms of quotient rule, chain rule, product rule, all those applies that we learned from chapter 2. Okay, so first one, 7 times e to the x. Well, e to the x is just e to the x. So first one, we have 7 e to the x. Let's do term by term. So this one is this one here, because e to the x is e to the x. Second one is a very easy one. You have done this before. Remember, all these constant, we kind of left it alone, so that's why 7 is there. So the second one over here, I'll in fact color code it. Okay, so that's an easy one. Bring down power, subtract by 1. So derivative will be 4 times 5. 5 comes down, right? So 20x raise it to the 4th power. So that will be a derivative for my green term. And then negative 3x, derivative will be negative 3. And then 21 just disappear. Constant is just a 0. So your final answer is 7 times e to the x plus 20x raised it to the 4 minus 3. Term by term. Okay. Let's do one more term by term. 1, 2, 3, 4. Again, I have 4 terms. Let me begin color coding it first. So I have the orange term as the first one. My second term here. Third term. And then the fourth term. Okay. Derivative of first one. Again, similar thing. You have e to the x. And then the constant is just there. So e to the x derivative is just e to the x. So I have negative 5 e to the x. Same thing. The 7 is just kind of like staying there as a constant. ln x derivative is 1 over x. Negative 13x is just negative 13. Derivative of a 4 is just constant 0. So you can do a little bit of middle term. Just make it simpler. Negative 5 e to the x. Negative 7 over x minus 13. So final answer. So you have bunch of problems to practice. Okay, so a bunch of problems to practice taking the derivative. More problem that you approach, you're gonna get better with these rules, derivative rules. So I have a couple more on the back. One more page. 3, 4, 5 is another just more exercise. And number 6, I have an application problem. And this looks very similar to number 12 on your homework. Okay, so more practice. First, use appropriate properties of logarithm to rewrite f of x. So they want you to do some rewriting and then find f prime of x. Now here's an issue. If I give you this form, this one here, right? There's no issue of taking the derivative of 18x. 18x is just 18. Now the problem is the second one over here, ln 18x. Why? I am given just ln of x, not ln of some number x. I hope you guys see the difference between the earlier one. Here, number 2, I'm gonna erase this one. This part over here on number 2, this is fine to use the formula because it's ln x. ln x. However, this one is ln 18x. There's some extra 18, and you cannot just say 1 over 18x. That's not true. I'm only given ln x. So here's the one that I mentioned earlier. We are going to be using some rules, right? We are going to be using some rules to rewrite that ln 18x. And I hope you guys can kind of guess which one I'm going to use. It looks like I have 18 times x, so it makes sense to use this first rule to separate it into addition. So that's what the first part is. Rewrite using the property. Well, first one is just 18x because 18x is 18x. Second part, this one, by rule, I can say ln of 18 plus ln of x. This is like 18 is u and then x is v. Okay, so I, in a sense, have 3 terms now. But that's pretty good. That's good. Why? 18x, now it's easy to take the derivative. 18x's derivative will be 18. ln of 18, that's just constant. So that disappears. So if you type it ln of 18, that's just number. You know, any constant disappear. So middle term disappear. And then last term ln x is right here, 1 over x. So your final answer is 18 plus 1 over x. Okay, so some homework problems and some exercise will require you to modify a little bit using the rules. So I give you a couple rules to help you rewrite. Use those, manipulate, rewrite into more terms so you can use either 4 functions. Okay, so that's a trick. Let's go to number 4. Number 4 is not a bad one. Again, 3 terms, so we will differentiate term by term. So derivative of y, 10 to the x, to me that looks like b to the x. b is where any number. So it will change to 10 to the x will be 10 to the x ln 10. That's my derivative. So 10 to the x ln 10. Middle one, e to e cube is a constant, so that disappears. Last term, negative 5x will be just negative 5. That's it. Okay? Done. Very simple. One more. Let's take a look. I have 3 terms. Let's see if we can use any of these. So I'm going to actually, just easier for me to have these rule in front of me. So I'm going to copy and paste. Copy and then paste onto the next page. So I have the rules in front of me. So let's see if I can use this one. The first one to me seems like I can use this one here. Log x base 7, so that's my b. 3x to the 5th, that's an easy one. That's a usual one that we learned in chapter 2. The third term looks to me negative 4x, that's like this one, b to the x. X is on the exponent. Okay, so let's apply. dy over dx. Looking at this one, so I'm gonna have log of 7x will be 1 over ln 7, 1 over x. So 1 over ln 7, 1 over x. Middle term is the easy one. Bring down the power, subtract by 1. But 15, x raised to the 4th power. This last term, negative 4, that's going to be 4 to the x ln 4. So negative 4 to the x ln 4. Done. Okay. So we did 5 different problems to take the derivative. So please use this example to practice more derivative on your homework problems. Okay. Last one is an application problem. It's a tangent, finding an equation of a tangent line. We have done this similar concept, horizontal tangent or tangent line back in chapter 2. So let's find out the equation of a tangent line. So obviously you see the word tangent, so I need to take the derivative. Okay, but what? At where? x is equal to e. So they give you the value x equal e. And then it's a line of equation of a line of a tangent. So we will use point slope form to find the equation of a tangent line. So let's do that. So first, we find the derivative of f prime of x, okay? And then substitute given x value as e. Okay, so my f of x is ln x to the 5th plus 2. Okay. So what is my derivative of a function? Two terms. So here, let's pull out our four formulas. This is what we are given on the first page of the note. Notice that we have ln x, not ln x to the 5th. Okay, so I cannot use this rule right away, but recall that one of the rules that we have to remember is the power rule. I wrote it over here. You can rewrite this power as product. So n times ln u. So that's what I'm going to do. Because once I rewrite it into product, then this is a single ln u, so I can use this one. Okay, so let's do that. So by one of my, so let me see. I don't want to use derivative notation because I haven't taken the derivative. This still is a algebra, so 5 times ln x plus 2. Now let's take a derivative. F prime of x, 5 ln x. We did very similar, right? 7 ln x is just 7 times 1 over x, because ln x is 1 over x. So this will be 5 times 1 over x, and this disappear. Derivative of 2 is a constant. So my f prime of x will be 5 over x. Now we are given x as a e, so let's substitute that. So that's going to be f prime of e will be 5 over e. You can write it this way, or this is also fine. 5e times negative 1. Either one is fine. Okay. Now, we are given only the x value, so we also have to find the y value associated with this, and I'm gonna use the original one. So we have an order pair, so when we write an equation, we have an x value and the y value, right? So now let's find the y coordinate. So we are given x equal e. So original one, if I have f of x as a ln x to the 5th plus 2, we plug it in. That's y value with the xe. So ln e raised to the 5th power plus 2. So y ended up being, using the calculator, ln e raised to 5th power, and then plus 2, we get 7. So this is the order pair, e comma 7. That's your x value, that's your y value. So finally, we have the point slope form, y minus y1 m times x minus x1. So let's plug it in. Here's your x and y that we found. X value, that's going to be your point, right? And then y value here. And then we have a slope. What was our slope value? That's our first step right here. Okay, so plug it in all this value. I have y minus 7, 5, e raised to the negative 1, x minus e. Let's put it into y equals mx plus b format. So distributing this, I have y minus 7, 5e raised to the negative 1x. This part over here, I'm going to have distributing negative 5. 5e to the negative 1 times e. This is the same thing as 5e times e, so it's just 5. Adding 7, my final answer going to be 5e to the negative 1, x. Negative 5 plus 7 is plus 2. Now you can change this one as a decimal number if you like. So you can see y equals mx plus b clearly. 5 e raised to negative 1 will be 1.839. So I'll round it to the 3 decimal place. So this is about 1.839x plus 2. That's my final equation of a tangent line. Okay, that's it for section 3.2, and then I will see you guys in 3.3 videos.